So today we're looking at the question, what is the relationship between distance, time, and rate? Or how do you move among distance, time, and rate when two of the three components are known and you're trying to find the other one? So today we're going to be looking at the distance formula and its variations. So perhaps you or younger brother or sister have asked the question, how much longer or when are we going to get there? So we're going to look at some tools today that can help you answer those questions using the distance formula. So the basic distance formula is rate times time. If you want to solve for rate, you can switch it around and it would be distance divided by time. If you want to solve for time, you can switch it around again and it would be distance divided by the rate. Whenever you have per in the middle of an expression, it's an indication of rate. So miles per hour, miles per gallon, cost per day, those are all examples of rate. So keep that in mind as we're going through the problems today. And it's expected that as you're looking through this video, that you would pause it, work the problems on your own, and then resume to check your answers. So let's look at rate first of all. If it takes Jill 15 minutes to ride a bicycle 4 miles, how fast was she traveling? So using our equation for rate, our formula, rate equals distance divided by time. So we have our rate of our distance of 4 miles and our time of 15 minutes, but we need to convert the 15 minutes into hours by multiplying 60 minutes over 1 hour. So our minutes cancel, and we have 15 into 60, which goes 4 times. Then we have 4 times 4 in the numerator and hour in the denominator. So 16 miles per hour is the answer to that problem. All right, so let's take a look at time. So how do you find the time that it took to go a certain distance given a certain rate? For example, if a car is traveling at 35 miles per hour, how many minutes would it take to go 5 miles? So our formula for time is distance divided by rate. So in this case, we have our distance of 5 miles and our rate of 35 miles per hour. So we have 5 miles divided by 35 miles divided by hours. So that equals 1/7 divided by hour. Or you can get rid of the hours, bring it up to the top, and it would be 1 hour over 7. And then so that equals 0.143 hours. And our question was asking about minutes, so we have to convert to minutes. So we multiply by 60 minutes divided by 1 hour. Our hours cancel, and we have a resulting 8.6 minutes is how long it took the car to go that fast. All right, now let's look at a multi-step problem. So from Missoula, Montana, driving east to Mount Rushmore, South Dakota, it is 683 miles. And both Missoula and Mount Rushmore are in the same time zone, the mountain time zone. So first part, A, what is the average speed Google Maps is using if it indicates 10 hours and 16 minutes of driving, not including stops? B, there is a Costco gas station in Billings, Montana, which is 337 miles from Missoula. If the car averages 34 miles per gallon and has a 14-gallon tank, and they start with a full tank, will they need to stop for gas before Billings? Next part, C, how many gallons of gas would they have used to get to Billings? Last part, D, what time should the family leave Missoula to get to Billings by noon? So again, recommend pausing the video and working through each of these steps, and then resuming the video to check your answers. So show your work and let's see how you did. All right, so working on the first part here. What is the average speed Google Maps is using if it indicates 10 hours and 16 minutes of driving, not including stops? So this is a rate question, and our formula for rate is distance divided by time. So the distance, the total distance to Mount Rushmore, 683 miles, divided by 10 hours and 16 minutes. But we need to convert our 16 minutes into hours so that we're dealing with the same units. So what you do is you take your 16 minutes, you multiply it by 1 hour divided by 16 minutes. Our minutes will cancel, and we'll have 16 divided by 60, which equals 0.267 hours. We add that to our 10 hours, and for our time, we have 10.267. So then we take our distance, 683 miles, divided by our time, 10.267 hours, and we get 66.53 average speed, miles per hour. So again, when you're solving for rate, it's distance divided by time. All right, let's take a look at the next part. So part B, there's a Costco gas station in Billings, Montana, which is 337 miles from Missoula. If the car averages 34 miles per gallon and has a 14-gallon tank, and they start with a full tank, will they need to stop for gas before Billings? So this is a variation of the distance formula, rate times time. Our rate, miles per gallon, and our time is going to be represented by the 14 gallons. So we want to know how far can they go on a full tank of gas. So 34 miles per gallon times 14 gallons equals 460 mile range on a full tank. So 337 miles is less than 476 miles. So no, they would not need to gas before Billings. The next part, C, how many gallons of gas would they have used to get to Billings? This is a variation of our time equals distance divided by rate. So the time, to find the time, we're looking for the distance of 337 miles divided by the rate of 34 miles per gallon, which equals 9.912 gallons to get to Billings. Then the last part, part D, what time should the family leave Missoula to get to Billings by noon? And our formula for time is distance divided by rate. So they have 337 miles to get to Billings, and the average rate is 66.53 miles per hour, which equals 5.066 hours. Now we need to convert our 0.066 hours into minutes. So we multiply that by 60 minutes divided by 1 hour, and that equals 3.96 minutes. So total time of 5 hours and 4 minutes to get to Billings. So the family should leave a few minutes before 7 a.m. In other words, by 6:56 a.m. to get to Billings by noon with no additional stops. So how'd you do? I'd be interested to hear your response and your result. Thank you. Have a great day.